Alright, so here's what's actually happened. If you want the long and short of why we skipped the chapter. Chapter 10 and 11, I don't know why exactly this happened. I feel like chapter 12 is almost intro into math 3. Because chapter 10 and 11, we did 10, right? But chapter 11, I think we did a couple parts of it. Yeah, 10 was our circles. So we skipped around, but we did the content from 10. Chapter 11, because I want to make sure and ask questions of how do I plan the rest of our week? So today we're doing combinations. And your homework will deal with both combinations and permutations because then the difference between them. Long story short, there's a lot more combination options than there are permutations other way around. There's a lot more permutation options than combinations because combinations doesn't order. It just groups. Permutations look at the order. So where we might only have one group, Chris, Hunter, Thomas, if I order, and I go Thomas, Hunter, Chris, or Hunter, Thomas, Chris, or Chris, that makes more if order matters. So that's long story short. We'll get back to that. But 11 deals with prisms and cylinders, volumes, and surface areas. So it's a short chapter, but getting into the fact that when we have a similarity ratio, like when we double the lengths, that does not hold true for the volume, right? Which we've talked about multiple times. When we double lengths, we don't double volume. It's actually that scale factor squared or cubed, depending on whether you're doing the big V or the volume. So just be aware the similarity ratios get manipulated. So if you had a cube that was 1 by 1 by 1 compared to a cube that was 3 by 3 by 3. Well, obviously your 1 cube is 1.
What is 3 by 3 by 3? 3 squared, 3 cubed.
3, yeah. So it's that scale factor cubed if we're jumping right from edge length to volume. Now, what's tricky is sometimes they'll say, an object with the same base with the height doubled, okay, then volume does double if it keeps the same base. But if it says every dimension doubled, that's where you got to be careful, or every dimension tripled. So just read those carefully. So this digs into the ratios of similarity between 3D shapes. Volume of a pyramid. How do pyramids relate to their corresponding prisms? What fraction?
1/3.
1/3. So I'm just I want to know what we want to do. No, this is me asking, do we need to review any of this? Would anyone like to review some of this stuff to gain more confidence before we get there? So this might be useful, 11.2.2 for surface area and volume of cones pyramids. So am I hearing that we could probably stand to do a day of review? Cones are weird.
Isn't it 2/3?
1/3 if we're doing volume. Yeah, volume of a cone or a pyramid's 1/3 the corresponding prism shape. So cylinders are a prism shape.
Remember, surface area was one of the lessons that really confused me in 5th grade.
So should I plan 11.2.2 to
I don't remember surface area of a cone.
And I might just make us another worksheet, like the circles worksheet. 11.2.3, the sphere. We could go ahead and talk about some of that.
I don't remember surface area.
Yeah, surface area of a sphere is weirder than even volume.
Surface area. What surface area is where? Oh my god.
Hmm?
It's just the surface area of the cone.
Yeah, or this. Lateral area of the cone. So we can talk about this tomorrow. Okay, so thank you. That was beneficial for my planning. So let me write this down real quick. We should do 11.2.2 and 11.2.3.
Interesting reaction, to be sure. I want to fail the chapter 11 test.
Who said we're taking a chapter 11 test?
Wait, what?
I don't know, but why are you freaking out about something you don't even know yet? We just may not take a chapter 11 test.
Isn't that like being paranoid?
This guy found, apparently in the homework, someone found the 700-gram negative gold.
That's the scratch. You do your homework. That's pretty expensive.
So I have this draw. Pick
We had 12
Yeah.
So I did the probability.
Yeah, it's 12
all the numbers different.
Yeah.
Alright, have like 30,000 chance to get it. 1 out of 30,000.
Yeah.
And I got it.
I need to check your math. 1 out of 30,000 seems real high, but not right now.
To get what?
I got a slime staff. I got 2 consecutive slime staffs in Terraria, which is a 1 in 10,000 draw.
Wow, I'm impressed, Satya.
Okay, so statistically unlikely events can still happen, right? So all because something is unlikely
They have to have
doesn't
that
mean
1
it
in
can't
10,000.
happen. Yeah.
The thing is,
So that's like
there's
when your
no
car gets
path
struck
to
by
that.
lightning and you're like, what were the odds of that? Well, yeah, all because you can ask what were the odds of that. Doesn't mean it's not going to happen.
A 1 in a million chance will
Happen like today,
will
probably.
happen like every 34 seconds.
Yeah, something like
If
I mean,
we're
with how
wrong,
many
if a 1 in a
people that,
million
yeah.
chance happens. But I'm not playing Terraria every.
The question is,
All right, can we dig into this so we can maybe have some
you
homework
have
time?
enough
Well,
data
that's what I was
to
doing.
have a 1 out of 30,000 chance.
Race
It's gonna
begins.
happen no matter what.
So, we are going to help the Spirit Club. I figured you guys would need a moment to react.
Like,
So we have Al, Barbara, Carl, Dale, and Ernie. Look at how conveniently they signed up A, B, C, D, E.
They're all
Would you
ghosts.
look at that?
Would you look at that?
They're
So,
ghosts. They're all ghosts.
we good? We want to first answer if each of them is going to have an officer position, right? Like president, vice president, secretary, treasurer, the whatever. Al, president, Barbara's vice president, Carl, secretary. Oh, are we not giving all of them? Yeah, I think on this one we're just going to allow 3 of them. So, if we have 5 people and we're arranging 3 of them into a governing board, well, 5 permutate 5 would have been easier. How many different governing boards could there be? I'm guessing you already put it in your
Would it
calculator.
be 3 permutate pods?
6.
It's how many do we have? How many are we picking?
So 5 permutate 3.
5 permutate 3.
But it's not because it's combination.
60.
No, this is still
Oh,
permutation.
is it permutation?
60.
Alright. 60, yeah.
Now, if we write out the work to show the justification, oh, I can't write on this. My computer's mad at me again. It's, yeah, the first option, well, that's not the work. That's what we type into the calculator. The first option, first place to fill, has 5 options, right? Because there's 5 people on the committee. The next, well, 1 person's already been chosen because you can't fill multiple positions. So if we don't have a graphing calculator, or if we can't remember, just think about the math. 5 times 4 times 3, which is 60. Now, we decide instead, though, that we're going to have a collaborative committee. We're going to choose 3 people that instead of having specific titles and 1 person outranks the other, are just all what real committees out in the world just call a member at large. So we have people that are members of the Spirit Club, but if I'm a member at large, I'm more important and I help make the decisions. That's actually my title with our fraternity alumni right now because I don't want particular responsibilities. I just want to help when I can. So if we just want members at large, how many different combinations of that group could there be?
A lot.
Is it
Less
5?
than that, probably.
A lot, but less.
A
Well,
lot of them, but I don't want to list. I don't want to list out like 30. You just do, and so you do like A, B, C.
what would I need to do to the permutation that we have to modify it to match the non-constraint situation that we now have?
5 permutate 5.
Oh, that's not what that is, though. We're not permutating now. We're just choosing
It's 5
an elected
C3.
board. They
Equals-
all have the same title.
It's 5C3 equals.
You're correct. It is 5C3 because this is a combination. No, wait. So you did it in your calculator and you got,
So would that be the
but why?
dual times?
I don't know. Wait, how do you
You
double 5? How do you do combinations?
The
Well, maybe it's
difference
that
Same thing
times
with
that.
permutations, but you click the NCR instead of NPR.
Minus. And combinations is actually a third of 5.
Wait.
Combinations will always be less than permutations if we're under the same constraints
Okay.
because a combination can have multiple arrangements, multiple permutations, right? So apparently what this is saying is every combination here has 6 arrangements.
Oh, so combinations are like combinations of different numbers, but the numbers can be arranged. Yes.
Again, I think you were too in your head when I started talking and you were late, and they're like, which is fine, but like I think you didn't hear me say this. Combination is just the group.
Okay.
Permutation is an order to the group.
Okay.
So it's the difference between here's my scout troop versus he is the patrol leader, he is the scribe, he is the quartermaster. Like so that's the difference. That's why there's more permutations, because I can rearrange people into different. And it's still the same group. But what? Like how? Why? What? Okay, let's compare a different situation. I'm going road. A 6th person joins the committee. From CPM. I'm just making up stuff so we can
But
dig
a
into
6th
this.
person is joining it even with CPM.
But I'm not even. I don't
You
care about
tried
the
to go
textbook.
rogue.
Okay, fine. What if there's 7 people? So let's work our way up. So if we do 6 permutate, and we're still going to do a board of 3.
We'll do just 6 times 4, 5 times 4 times 3.
Ooh, no.
6 times 4 times no, 6 times 5 times 4.
So this is 120. How many combinations?
Is it? I'm guessing 20. Is it 20?
It is. Would be
Wait, it's divided by 6. I hate you, Chris. Still my
divided by
partner.
6.
Always?
No,
because that one. Well, in each of those it has been. Maybe it's.
Let's
divided
totally
by
change this
twice.
situation.
Oh wait, maybe it's divided by twice the.
Let's try some things. Don't just keep throwing out ideas. We got to back them up with why. Let's take a 12-person group, right? 12-person group, and we're going to choose president, vice president, secretary, treasurer, which is normally what a panel would consist of. So let's choose 4. What's 12 permutate 4? 11,800 what?
So let's divide that by 8. Divide by 8. So 495, right? Now do 12 premium. That doesn't seem right.
Yeah, that might be right. 495 was right.
495.
1180.
Do 12 combinations.
495 times 8 doesn't equal that. That's not that cheap.
11,880 divided by 8. Maybe it was just a coincidence.
So wait, what would get us here? What division?
Is it 12?
It's not 12.
It's not 12.
It is 24.
24.
Man.
And really, so I'm going to draw this arrow going either way, because we could divide or multiply. Did we check this? We're sure this was right? That this was 6?
Oh no, I trust him.
Well,
No, wait, what?
well,
20
did we
divided
check?
by 20.
Did we check this?
No.
That this is actually 20.
I don't think so, no.
Okay. And then this was also 6.
So what's up with that? It's just a coincidence. It's going mental. Well, it's not just a coincidence, it's math. It could be. There aren't really coincidences in math.
What's
Are you
12
sure
permutate
about
5?
That is 950.
Apparently there's a correct way to spell coincidence.
What is it? 95.
Wait a minute. Just like coincidence.
Hey guys, can we not spend our time trying to spell a word that may or may not be real when we're investigating math that you don't understand yet? If we were doing something that you had mastered and you could just like, I wouldn't care. Well, like we don't know this yet, right? We're trying to figure this out. So help us figure this out. We need you.
Because the thing didn't change. Like the multiplication factor didn't change.
It's 792.
No, they.
And then it's 120.
It's 120?
Divide, yeah, times.
No, that's.
Maybe.
Maybe it's as we change the second number.
No, it's not.
Yeah, but look.
Do
12
12
2 were 6.
Can you do 12 to the 5th divided by 5?
12 to the 5th?
Oh. Wait, what's I mean, that's probably nothing.
12 to to the fifth
400.
is
No, 400.
248,832. You said divide by what?
49,766.4.
It's a bad number. Yeah, it's not even a whole number.
Probably not.
No.
Alright, I think these big numbers are going to get a little bit too hard. Right? I think we should back up for a second.
Let's do like.
Wait, how do we even get
Let's do 7 permutate 4.
7 permutate 4. Okay. So that'd be 7 times 6 times 5 times 4. Right? What is that? Well, that's the
The only
point.
thing that can. 7, 4. Well, it's 7 times the 4 plus 1. So. Oh, that's a combination, yeah. 840. What's the thing with that?
Wait, how do you get the combination?
Press
NCR, it's in here.
math.
So really, this is saying we have 7 people to choose from. 7 people to choose from. 7, or sorry, no, it's not. So we're still saying that, but that's the permutation, right? The issue is how do I go from permutation to combination, and that's what I'm trying to get you guys to figure out.
If you have a pass,
I think I figured it
The
out.
switch between them is the factorial of the amount of spaces. Because like 4 factorial is 24, I think.
So wait,
There's like 1 times 2 times.
Jacob's hypothesizing the amount of places we choose factorial is our scale factor here. Let's check this. We chose 3 places. What's 3 factorial? 6. We chose 3 places. 3 factorial. We chose 4 places. What's 4 factorial? What's 5 factorial? You might be on
Jesus
some
Christ,
here.
Jacob.
Yes.
Congratulations. So it's the bottom right number factorial.
So this, the permutation, so this was NCR, so Chris is saying divide by R factorial.
Chris, Jacob.
Jacob, so you were talking at the same time saying Jesus Christ and it got in my head.
You're not saying the Lord.
He doesn't have anything to do with this. They didn't do very tough math back then. He was all like, math problem, look at this water, it's wine now. No one ever made him do math. And when they tried to, you know what he did? Flip the table.
Yes, it did. With a whip.
That's because
No, so the story when he was in the market and he was all upset about the trading and all, my joke with that is like he got upset about the math and he flipped the table. Because what he was really mad about was there was trading happening in the in the church, in the temple. So like the temple isn't a market, right? It's a temple. It's a place of worship. So he got very upset. But my joke is that it was nice. So let's formalize this. NCR, if we didn't have a calculator.
NCR equals NPR divided by R factorial. Yeah.
Now, great, but let's formalize this a bit further. We found NPR by doing what?
That would be the equation, which is n factorial n minus r to whole over n minus r over.
Wait, what?
Yeah,
N
over.
factorial.
Over n minus r to whole factor. You'd have to do it over and then factorial. Yeah. So you can factor that out and you get n. Can you do n factorial?
And then this?
That entire thing over something other thing. So let's see. Oh boy.
There's got to be a way to clean this up.
No, the second thing is as clean as you're gonna get.
I feel like it's not, otherwise you wouldn't be bringing this up.
Well, I don't know. I'm just saying. That doesn't seem
I
that
feel like you do
clean.
know, Mr. Hudson. You probably does.
I feel like we're being deceived.
You can multiply everything by Senor.
It's just this. It's n factorial over r factorial times n minus r factorial.
Math.
No, you put the n factorial
feels like an n factorial over again, but with n and r.
Yeah.
N is n factorial
R factorial times n minus r
Exclamation points everywhere.
Everyone's talking at the same time. What?
Is it n factorial over r factorial times n minus r?
He explains. Well, let's check it. Checking it and go. Go to the board.
Go do some stuff.
Go do board. Show your work. Go do board.
That's one.
Perfect.
No, it looks like a spaceship.
It looks so ugly.
I can't see it.
Did you
Yeah,
say
right? Ah! This makes me want to hurl. And not like a disc. It makes me want to hurl.
I did this.
This, not as bad, but if I keep trying and keep pushing for better,
Just accept with what you have.
that looks a lot nicer than this. Right?
Now let's check it.
Okay.
Turns out everything.
Let's try
20 and 4.
with 20 combined 4. So our new situation.
No, I need to.
Is that like some 8th grade thing now, just saying suffer?
No, that's.
It's just me and Lauren.
Yeah, you did
It's
a
your
lot.
little peanut gallery over there.
He did a lot.
Try it. Somebody type in your calculator 20 C4.
C4. Excuse me.
I love that.
I'd like to order 20 C4.
Sorry, what is it?
116280.
116280.
Yep.
Wait, that's the permutation.
What?
Wrong. What?
Wrong.
Yeah, that would be a big combination.
Five.
Four, eight, four, five.
That's the combination. It's 484.
I thought this seemed like a lot for a combination.
A little much there.
A little
That's how
much.
much 20 things a
Chris,
C4
give
is math.
my calculator back.
Guys, there's a stack of calculators.
Whoa, if you multiply that by 24, you get.
So if we try this though, n factorial, right? 20 factorial.
We can't use n though, because we already have.
What do you mean? I'm trying to use this formula that we said we think is true.
Oh, okay.
N and R are 20 and R4. So 20 factorial, 4 factorial, 20 minus 4.
How would you type that in a calculator?
You go to decimals.
Well, it's.
There's
Four, eight,
gotta
four,
be
five.
an easy.
It works. 485.
Wait, Nen, how did you do that in a calculator?
Did you go to decimals?
So
Yes, it
I'm
does.
thinking
Go
of
to 48 exclamation mark.
There we go.
this
We already have our. Where's the
I just said
What
something.
do we use
Oh,
question
yeah.
marks for in math?
I know, but it's a whole lot more to be able to be like, so this isn't 20! 20 factorial, right?
20!
Is there anything gonna happen here that could make our life easier? Not really.
Well, can you divide the 20 factorial?
You have to multiply
Sounds like you're doing aerobics back there.
What
What is 20 factorial? Hold on. Think through this for me. What is 20 factorial?
that.
Not what does it calculate to, but what does it do?
20 times 19 times 18 times 17 times 18
So
times.
right? Keeps going.
So
Wait,
like
that's
today and then
What is
oh
16 factorial?
No, that's an E. That's right, that's right. That is mucho gusto right. What? Oh. Oh, that makes sense.
So you just do.
Wait, wouldn't that just be 20 factorial over 20 factorial?
no.
But 4 factorial times 16 factorial would be 1. Wait, no. I'm thinking. Well, I mean, our situation is correct.
This part of this factorial will reduce out. We're trying to get away from the word cancel. Why? Because it's wrong. Cancel means it goes away. It reduces to 1.
What happens after that? It goes away.
No, because so this we keep the 20, 19, 18, and 17, but the 16, 15, 14, those all reduce out, and so we could just write it like this. So when we look at doing combinations, which, by the way, if anyone asks you what you've been doing in math, the fun way to talk about this branch is it is called combinatorics. No, combinatorics.
It is correct.
Wait, we learned how to play
Hey guys, why when I stop talking for 10 seconds do we have like Celtic chants and everything else going
It's
on?
not Celtic, actually.
Do you think I care at this moment?
Probably not.
So, while there is a way to clean this up and make things reduce away from each other, what we hypothesized, which is why CPM puts it in tomorrow's lesson, not today's lesson, is correct. If we start with NPR over R factorial, the cleanest we can get it to really is N factorial over N minus R factorial, R factorial. Now the reason, well, okay, I guess it depends on your brain. Depending on how you arrange that denominator depends on how it's easy for your brain to think about.
Well, I mean, hold on. Didn't we just do it like this, though? We did it 20 factorial.
Over.
Yeah, we did.
20 minus 4 factorial.
So can we put 20 so can we do N factorial divided by N minus R and then put that? That's the same thing that we just did.
Are we good?
But that's...
Did you circle back around? Are we good?
Yeah.
Okay. Questions on how combinations relates to permutations. Now, really, what this is, your N factorial that Jacob made that connection to, that N factorial tells you how many ways there are to be arranged. If we're choosing 3 people, there are 3 times 2 times 1 ways to be arranged. If we're choosing 4 people, there are 4 times 3 times 2 times 1 ways to be arranged. Right? That's your fundamental counting principle. That's where factorial first came in. And the lesson that we skipped is saying when we're trying to choose this many objects and it's all of what we have, 5 times 4 times 3 times 2 times 1, we're like all the way down to 1. That's where our denominator comes from. Is just those number of arrangements. Questions? Ponderings? Comments? Opinions? Wrong statements that you've heard online and think are true?
22 out of 19 ducks have spots. Actually, ducks is more thirsty.
Oh, one general note. This has just been generally agreed upon.
What? For example, oh wait, no, I'm looking at the wrong math note box.
Because otherwise, certain things fall apart.
0 times 0 equals 1.
So, no, 0 factorial. Because really, one way to talk about factorial is it multiplies all the way down to 1. Yeah.
1 times 0 is...
I know. So we've just generally agreed that to make all these other cases that we talk about hold true and not have any issues, 0 factorial is 1.
What's 19 factorial? 0. What's 30 factorial? 0.
This is like 9.9.
Also 0.
Well, so think about it. If you have a group of 10 people and you're choosing all 10 of them, your n minus r, 10 minus 10, I can't make it 0. If I make it 0, the problem's unsolvable. So when we choose everyone from the group that's where this situation matters, the 0 factorial. That's why we had to agree that it's just going to be 1.
What's the homework?
And really, guys...
You say it's 1, but it's not really
But,
1.
so, let me wrap this up and put a bow on it. Really, this only matters here in this denominator section. I don't know why my cursor keeps like disappearing. In this denominator section, when we can't divide by 0, right? That like you're never allowed to divide by 0. That's why we made this rule. Really, the only reason we made that rule was right down here, the n minus r factorial. Popping back over to here. All right, so let's talk about how improbable things are. Now, this isn't even how the lottery works, but if you just have to get the numbers, an order doesn't matter, right? They're trying to make the lottery more friendly to you. If I play my birthday, I can have 4, 30, 89, or 89, 34, or 8. Like, I can arrange them in different orders, and it doesn't matter. So, if you have 56 numbers, and you have to choose 6, how many different combinations are there? So, 56, C, 6.
That's a big number.
Really?
You C, not P, right?
Yeah, C. 56 combination 6.
Yeah, that's pretty big.
Okay, what do you get?
3, 2, 4, 6, 8, 4, 3, 6.
Yeah, he's right. He's right.
32.
So I forgot I can't write on that board.
32 and a half million.
Yeah, don't do the lottery.
Over
Chances
6
you win.
factorial are bad.
No, like you're never gonna win.
Yeah.
Hey, no. Unless you want me to take that away, no. I don't care if it's in your mouth. We're not playing kazoo.
436.
36.
Guys, that's not even that many numbers. 56, that's less than the amount of numbers in bingo.
Dude, how many numbers even exist?
And your chance of getting them is 1 out of, right? Just to choose the right set. Now, let's try to make it a little bit easier. What if we only choose 5? Let's just compare. We don't even have to write. So what is like 56C5? So you could actually just grab it and change the 6 to a 5.
Wouldn't that be even less?
Or is it going to be less options or more options?
Yeah, less options.
What do you get?
381, 98, 160, 16.
What?
16.
3819816.
Yes.
Yeah, so less options.
Yeah, less groups, right? So less numbers will make it have less groups. Will make your chances go up. Because I mean, like, think about it. If you only have to pick 1, there's 56.
Are you encouraging
chances.
us to become lottery addicts?
No, and this isn't even how. This isn't even how. So here's me encouraging you to never spend your money on the lottery.
Because you have like no chance.
With 5, there are only 3 million chances, right? So let's change this game and say 5. But now, let's look at if the order does matter. And I have to nail it in the right order, like Powerball actually works.
It'll be 4, 8, 8, 3, 7, 7, 9, 9.
4, 8, 8, 3.
7, 7.
Wait, how did you get that? Shouldn't it be 4, 5, 8, 3, 7, 7,
I don't know.
9, 2, 0?
56 of permutation 5.
Yeah.
Permutate
It's
5.
4, 5, 8, 3. You had 4, 5, 8, 3 as well. You said
Then I
8.
misheard you.
Oh, you're an extra 8.
No, you just wrote a 5 instead of 1.
And 8 instead
That's
of
an
5.
extra 8.
Yeah.
So, guys, if the order matters, and you're going in there and you're picking 5 numbers, and they cannot repeat because they can't, they have little ping pong balls that go around in a machine and they spit out. There are 458 million options for the results. Now, this is why the jackpots get so high. And people are like, oh my gosh, I gotta play. No wonder no one won. There was one. Well, okay, that's wrong. There's one winning set of numbers. That doesn't mean there's one winning ticket. You could choose the same numbers as me. They don't care. But guys, somebody has to win for the jackpot to get paid out.
Mr.
So what happens is it just cycles. And the reason that every so often we have crazy big jackpots is the math that says you're not going to win has happened over and over again for a long time. And for like a couple months, no, this is really what happens. For like a month or two, people don't win, and I'm not playing, right? Because who cares? The lottery sucks. And then the jackpot gets super high. And what happens? A lot more people play. Most people walk in and say, give me 5 tickets, and the computer randomly picks their numbers. You can pick your numbers, or the computer can randomly do it. Then, when the pool of people playing doubles, triples, quadruples, finally somebody hits their numbers, and it pays out.
So, if we are all like going with this, I found this really cool thing that was like.
Was that like the obvious ending? Was that how you know I'm done with this?
That was it.
No,
The
yeah,
question
yeah,
is,
yeah.
how high does the jackpot have to be for your expected value to be greater?
Your expected value is never going to change.
Well, like, if the jackpot chance stays the same, then expected value
This
is
is
up.
this is being left-handed. This is when it is when it's
Why?
powerful.
Why?
This is diamond
Why?
table. That's that.
1.586 billion is the biggest it's ever been.
It's that one. I want that.
And that was last year.
4, 5, 8, 3, 7. I'm gonna do this. Okay.
Now the winning payout was probably about 40% of that.
You have to get that. You have to get that single dot. So like to visualize you winning this, if the computer picks a dot,
And
you take that
there were
exact
3
same
winning
dot.
tickets. Right? So not only did it hit, but there were so many people playing, 3 people won.
It's the lot. It's the chance that you.
Yeah, you split it. You have to split it up.
Hold on, Mr. Hudson. Or not.
So the lump sum on a winnings of 758 million, which is actually better than I anticipated. The lump sum payout was not actually that. That's not a real check. Was 480 million, which is better than I like. That's more than half.
Look up.
Yeah, it also depends what state you're in because of the taxes. Look up what?
Wall Street Journal, 1 in 290 million. 1 in 900. No, 1
Actually,
in
the-
292
That's actually
million.
really funny because the expected value for
Lottery.
playing is 3.5.
One in what?
No,
For
292
playing
million
that one, the
lottery.
expected value is $3.5.
It visualizes the chance of you winning.
The question is, how much?
This?
Scroll down.
Okay, now there's the Powerball.
Now press jump ahead
And this is it scrolling down.
at an insanely fast pace.
That's 1% of.
So like visualize that computer would randomly pick one of those dots, and you have to pick the exact same dot that the computer picked.
So on our math, or they did the math or whatever, somebody had posted like, "Hey guys, send me good vibes. I just spent all my savings on lottery tickets. Hopefully I win." Da da da. And somebody did the math of how much would it cost to buy enough lottery tickets to hedge your bets that like you would win. And the problem is you have to have the money up front. So they were hypothesizing like, is the money you're gonna win enough to cover back the amount of tickets that you would have to buy to have a decent chance at winning? Not even like you're gonna win, but like even like a 50-50 chance, right? It's like right here. And even then you only have a half chance. Somebody who bought 1 ticket could still win. It's over there. Just do 6 of them. Yeah, from tonight's homework. All right, that's
Now,
enough
if you bought
for today.
all of the lottery tickets,
No, 12 1 2 is
And no one else can buy any.
you
Then,
would
hey,
value it.
Eventually you'll win.
Or what if you did like, what if you went every time somebody bought a lottery ticket, you like licked it, and you're like, this is mine.
That's basically that is very good rules of food. It's not your food anymore.
You're just teleporting everyone.
He spent like $10,000.
Fine.
Yeah.
And I don't think it's
Well, yeah, because your odds are still tiny.
Someone poisoned.
It's like stupid small.
Uh,